I'm John Ellis, the R&D manager of Labtech Engineering here in Thailand, just outside Bangkok. And in this short video, I want to explain our ASTM cooling press and demonstrate how the press is operated. But before actually describing the ASTM cooling layout, why do we need ASTM cooling anyway? Well, the reason is because with normal cooling, traditional cooling of a normal press, we use mains cooling water, and the cooling rate from the hot pressing is very rapid initially. We get a very rapid cooling to begin with, but as it gets cooler, the cooling water cools it down relatively slower. So we get a curve that sort of gets shallower and shallower and shallower, and eventually it'll stabilize at the temperature of the cooling water. Now with ASTM cooling, we have controlled temperature of the cooling water and controlled temperature of the pressure, so that we've programmed the cooling rate so that we get a very uniform and linear cooling rate, and according to the ASTM standard, it should be 15 degrees C per minute. Now with a conventional cooling of a press, the temperature of the cooling water, which is sort of mains, direct mains, that can change temperature, so the cooling rate will change. The water pressure might change, constant fluctuation in mains pressure, and again this will change the flow rate and therefore the cooling rate. So we get a very sort of non-consistent molding with conventional cooling, and the rate of cooling affects the crystallinity, the amount of crystallinity, the type of crystallinity, which in turn affects the properties of the molding, what we're making on the press. So with ASTM cooling, we have a constant cooling rate every cycle. So we can compare sample to sample to sample because we're getting exactly the same cooling conditions each time. So this is why we use ASTM cooling, even though it's much more involved than a standard ASTM press. Now, ASTM cooling consists of three separate units. We have the press itself. We have a large chiller unit here, and we also have a large capacity water tank, which is temperature controlled. And here we have the chiller unit, rather large unit. It's cooled with a fan, air-cooled chiller unit. So we set the water temperature to whatever we need on here to give the required cooling rate. And finally, we have a large capacity water tank, which is around the back of these two units. Here it is. So the chilled water from the chiller comes to here. It's recirculated. So we have a large volume of water in here at a particular temperature. And that water is used for intermittent bursts for cooling the mold and the platens down at a constant rate. So three quite large units: the press, the chiller, and the water tank. So let's do a molding, see how it all comes together. When we're doing hot pressing, if we don't take a molten sample from a two-roll mill and we're using pellets, which are hard, then we need to preheat the pellets to soften them or even melt them before applying the full pressing force. And we have two proximity switches here. So as the bottom platen rises, this little plate here will pass over here and over here, and one of these is for stopping the platens so that the pellets can be preheated. And then after that, the press would close under full molding pressure. And after a short time, the press will open for degassing to let out any gases like moisture. And this will come down to this other proximity switch, and then immediately go back and complete the full pressing cycle. So these two are for venting and for preheating. And we can set the positions of these. And there's a calibrated scale here for recording the setting. Okay, so this is the control panel for the press. This is the touch screen. Now on this touch screen we have the home screen, which is this one. If we press this next icon, this is the operating status. It tells you where in the cycle you are. If you press this one, you need to input a password, which is 5678. And here we can set the preheat time, or it's called the contact pressure, or the contact time, preheat time. It's for heating up the pellets so that they soften or even melt before we apply full clamping force. And we have units of minutes or seconds in the right column. So we set the preheat contact time for 5 minutes, preheating. Now pressing time, this is the time before we do any venting. Venting is opening and closing the press. Now we don't need that when we're making moldings from polyethylene or polypropylene. So we've disabled that. So we will not have any degassing. And full pressing for 3 minutes. This is the final, after the preheating and the contact, the press will close, we'll get full pressure, and that's maintained for 3 minutes. Now these times are according to the AST standard. And number 3, number 4. And when we're running the test, we can have a graph, a real-time graph, which displays the pressure, the molding, or the platen force in kilonewtons, and this is the green units are temperature. So we will see the temperature should come down in a linear straight line at a cooling rate of 15 degrees C plus or minus 2. And we have upper platen and lower platen, and one is blue, one is red. These should come down at the same rate. And down here, these are the controllers for controlling the cooling rate. They've been specially programmed. This is the actual temperature of the platens. And set point, this is the calculated temperature according to the program. So these should be more or less the same. Same over here. The lower black part is for the lower platen. Here, the black part is on the upper, so that's the upper platen. So set point 175, and it is 175. We have this button, which is the full cycle button. This is to open the press at any time, and this is a reset button in case an alarm goes off. So this is the control panel. So now we will prepare our sample and do a molding. So here we will prepare our material for molding. This is the mold. It's a very simple flash mold or a picture frame mold, because the center part looks like a picture frame. This is one part, the bottom part, say, highly polished stainless steel sheet. We put, according to the standard, we can put PET film on the polished plate. Then the frame. So we will weigh out the pellets, and in this case, for this size mold, which is 5 millimeters thick, we weigh out 43 grams. This is LLDPE. The actual molding works out to be actually 41 grams after trimming off the flash. But we should add extra for flash when we do this molding. With this kind of a mold, this flash mold, we always need extra material to create flash. So we put that in the center of the mold and even it out as best we can. It's not so critical. Then we put on another layer of PET, in this case, polyester foam. Put on the top part of the mold. Then bring that to the press, which is already up to temperature of 175 degrees C. Put it more or less central on the platen so we don't have any unbalanced forces, and then press cycle. This is it's fully automatic cycle now. The pressure, well, the pressure will not be recorded because this is contact pressure now. The platen stopped because that little piece of metal passed the proximity switch. So now the preheating time has expired. The press has fully closed under full pressure. The pressure has gone up here on this pressure gauge, which we can set to whatever we want on using this pressure regulating valve. And you can see from this screen here that we're now in the status of full pressing, which means the full clamping force is taking place. So we're doing hot pressing at the moment. It was set at 3 minutes. It's now at 1 minute left. After 1 minute, the heating will start cooling down from 176 down at 15 degrees C per minute in a linear fashion. And after the cooling has finished, the press will open, but before we can do another hot pressing, we have to remove the water that's in the platens that's being used for cooling. So we've programmed this so that compressed air will force all of the air out of the water channels, and that will be diverted back to that large water tank behind the press. And the duration of the air blowing to clear the water out of the platens is set by press this icon, put in the password, press this second icon or number 2 icon, and the last item on this list is the air blow time. So you can put in whatever blow time you want, 60 seconds, 1 minute, and that should remove all of the water from the platens before we can do any reheating of the platens. Now this, we can see how the cooling is going by going to here. And this is a graph of the cooling. We have the pressure in black units, very linear, as it should be, with this kind of flash mold. And this line, which looks red, but in fact it's red and blue. There's blue dots and red dots. The blue represents the upper platen, this one, and the red dots represent the lower platen, this one. And you can see that it doesn't start linearly in the beginning, but then it kind of stabilizes, and then it settles out, and we get a nice linear cooling curve. So if this line is within plus or minus 2 degrees of the theoretical line for 15 degrees C per minute, then that's within the ASTM standard. So when the cooling gets down to the set temperature, the cold temperature, the cooling will stop and the press will open and the air blower will blow air out. So we can see that the line is quite linear at 15 degrees C per minute. And now that's the end of the cooling step. Press opens and we can take the mold out. But now air will be passing through the platens to remove residual water and blow it back to the tank and leave the platens dry for reheating. Remove the polyester backing. Now we have the final product. We would just need to trim off this excess flash using a sharp knife or blade.